One of the main targets for breeding is, of course, disease resistance, because potato is subject to many different diseases. And one of the main disease problems is, of course, late blight that caused the Great Irish Famine in the mid-1840s. This disease is due to a pathogen that is called Phytophthora infestans. And this pathogen is also very famous in plant pathology because it's the first case where we had an actual demonstration of the germ theory. It was actually a biological agent that caused the disease. Late blight is still very much a problem now for growers, almost 2 centuries after its introduction in Europe. That's why breeding efforts for blight resistance are still a major goal for potato breeders to this day.
I'm coordinating the project COFREE, which stands for Innovative Strategies for Copper-Free Low-Input and Organic Farming Systems. Copper-based products are used in agriculture, especially in organic farming, but they also play a role in integrated farming for resistance management of pathogens. On that background, the European Union has funded and is funding research projects that are working on the reduction or replacement of copper. There are 20 project partners involved in the project. Several are research institutions that are dealing with fundamental and applied research. We have partners that perform the field trials, and we have small and medium enterprises that are working on the development of alternative compounds. The idea of the project is to build strategies that integrate different approaches, and we are going to tackle the most severe diseases and involve the most important crops with respect to copper use currently. So we decided to work with grape and downy mildew, with tomato and potato with respect to late blight, and with apple and apple scab. COFREE is a modular system which brings together different approaches, and these 4 approaches are the following. One is the use of alternative compounds based on microbial origin or on plant origin. And here we use compounds that have either a direct effect on the pathogen or those that have an inducing effect, induced resistance, which means that they strengthen the plant to defend themselves against the pathogens. As a second pillar, we use decision support systems, and decision support systems are already known and are already used in agriculture. But within COFREE, we are going to develop them and adapt them to the use of these alternative compounds or to the use of tolerant and less susceptible varieties. And the 4th pillar is the use of less susceptible or resistant varieties. For example, in potato, a lot of work was done with breeding for late blight resistance of potatoes. So of course in COFREE we do not do the breeding work. We use resistant and tolerant varieties or less susceptible varieties, and we address one further aspect which is important in that respect, and this is the consumer acceptance of new varieties.
Welcome to INRA Prudenien. It's the research station on potato breeding and genetics. The whole story starts with the use of genetic resources. That means wild relatives of the cultivated potato. And you've got some of those species around here. The large diversity of flower colors, shapes, etc. Here we have a collection of about 10,000 clones that can be used for the breeding programs. So here we are in a greenhouse to produce the parents or grandparents of varieties, so the advanced breeding material, incorporating resistance from the wild species. So now we are in the field with the resistant varieties being tested. Those varieties, as you see, are very efficient, but still the pathogen is able to establish itself, and you can see the symptoms in the leaves. So it's important to maintain that resistance for as long as possible. And that comes from a systemic approach where we have both the resistance of the varieties and an extra efforts to maintain that resistance with some sprays, limited sprays, with either copper or alternative products that will reinforce the resistance of the variety and make it more durable.
Nous avons trouvé donc la recherche a développé de nouvelles variétés. Nous avons diminué pratiquement notre volume de cuivre, notre aspersion de cuivre a été divisée pratiquement par 2. Donc ensuite, nous avons donc la variété Alliance se situe ici. Nous espérons avoir de très bons résultats et voilà.
Here we from the Louis Bolk Institute have a demonstration field for the resistant cultivars compared to the standard varieties, because farmers want to see what the performance is in the field, because not only late blight resistance is important, also the other characteristics of a variety is important to make it feasible to grow in the field, but also to see how they perform so that they are attractive for the retail. We have already 6 late blight resistant varieties on the market, and they have different qualities. Some are a bit mealy, others are firm cooking, some are white flesh, some are yellow flesh, or in between, have different maturity. We work towards a new assortment of late blight resistant cultivars.
We sell organic potatoes for years now, and one thing I didn't know was that the potatoes was used copper to grow them. So now we know that problem. We want to contribute to the solution, and the solution are the new robust potatoes. Yes, and we had also different recipes. A recipe that Astrid has made.
We like to that the customers could taste all different kinds of potatoes. So for every day in the week we had a special recipe. Well, they liked them, they took them all with them, and they want to try it.
And we learned that our customers want to contribute to the solution. If you tell them how the things are, they understand, and it's not so. It's quite easy to switch to the new robust potatoes